Great. So once again, thank you for being here today. We are really excited to share you the new version of Packmind AI, which is pretty new based on what you may know of our previous solution. The idea of Packmind AI is really to be able to capture the technical decision within the team. So we use AI for this, and we will try to capture every technical decision, every context that your company or some teams may have. And then the technical leaders will be able to validate those practices, and they will be automatically detected within the AI. And within every AI coding assistant like GitHub Copilot or Cursor, I will make a quick presentation with the GitHub Copilot at the end of this presentation. So the idea of this capture is, for example, to plug Packmind into Git directly, so into GitHub, GitLab, Bitbucket, or Azure DevOps. And Packmind will look at the comments that has been pushed during the merge request, and we will discover the most repeated comments and the most interesting ones. So based on the AI and some clustering, we will discover the most repeated comments and transform those comments into detectable rules, what we call best practices into Packmind. And we will do the same with every wiki or static content you may have. So it could be some markdown files, it could be some architecture decision record on Confluence or Notion, etc. Or it could be any static content you may have, for example, some changelog for Docker, for Ansible, etc. Or some Medium website about best practices in React or accessibility or security. You can, in fact, for example, copy-paste the top 10 OWASP, and you will have generated practices into Packmind that may be automatically detected within the IDE. And we still have the capability to manually create practices from your IDE. So directly from your IDE, you can select a piece of code and say, okay, this is a bad example of practice because it leads to a security issue, for example, or this is a good example of a practice. And we will apply this now in the new code for every React project, etc. So you have those two capabilities to detect manually a new practice or to let Packmind generate a practice for you. And the first one would be the one that will generate the most practices in the future. And then those practices will be validated by the whole team or just the technical leader or the architect in the companies. So the workflow has been really fastened. It's simpler now to just validate some practices. And once the practices will be validated, they will automatically appear within the IDE, like SonarLint, if you know that. It's like a linter, but with your own custom rules, directly based on your Git command, for example. And we will see at the end how we integrate Packmind into the AI coding assistant tool like GitHub Copilot or Cursor. We have now multiple ways to integrate with those tools, but the more interesting one is the last one with the agent mode. So with Copilot or Cursor, you have this agent mode that will allow you to run not only code generation, but also to call external resources like Packmind. So we will see at the end of this meeting how Packmind can interact with these as an agent mode and just amplify the power of those tools. So for example, for the first capture that you can have with Packmind, it's from static content. So if you start using Packmind with your company, you will maybe already have some best practices into some architecture decision record like this one, or some documentation in Confluence, etc., or some markdown pages. So directly from those static contents that maybe no one can read, because when you are in your IDE, you don't go back into Notion or Confluence to review this documentation. You can just select everything, every text that you may have, and direct into Packmind. So here I'm in the UI of Packmind. So this UI is used by technical leader or architect, for example. And you have those two sections, inbox and practices. So the practices list is the list of practices you or your team have validated for your space. So everything in Packmind is gathered into spaces. So you can have a space for your team. You can have a space for a language, for example, for the Java teams within the company, or you can have a global enterprise space, for example. And you can inherit from spaces, etc., with your practices. So in this inbox section, you will have every practices that have been generated by the AI or just pushed directly from your IDE that will appear here. And the idea that has a technical leader, you can review those practices and validate those if you think they are interesting, or you can edit or reject them. And for the first way of creating a practice, you can just click on New, AI Generation, and here is where you can generate practices for every languages. We even tried it with COBOL, for example. So you can say, okay, this practice is about Java. And there you can just select the practice or the static content you have on your company, paste it, and once you click on generate, it will generate a practice like this one, for example. So from this content, it generated this practice. Use repository interface for domain layer integration. So you will have a name, a description with the structure, what, why, how to fix, and important, some code example, some positive example and negative example, one positive, one negative, with a description of why this is a negative example and why it is a positive example. So if you already have some code example with do, don't, for example, in your documentation, those examples will be taken for this description. But if you don't have any code example, Packmind will generate one for you, one positive and one negative. So you can still edit those examples, but normally it really reflects the practice you want to push. The idea is for some new developer, for example, in your company, to understand practice in 10 seconds. And the other way to generate practices is directly from the merge request command. So if you click on that, you will have the list of the repository you connected Packmind with within your company. So it works with GitHub, GitLab, Bitbucket, and Azure DevOps. And for example, here, I just added a comment to someone to say, okay, here you are catching an error and you are adding into the payload the error message. But by doing this, you will lose the stack trace and a lot of information about this error, which are really important to understand why this error had just happened. So I added a comment 3 months ago to someone by saying, okay, add the full error in the payload instead of the message only. This is a kind of comment that I may repeat because maybe someone else within the team will make the same mistake, etc. And maybe within the code base, there is still a lot of error.messages in those catch section. So with Packmind, these practices, so these comments will be transformed into practices. So you can see here that when you start by using Packmind, you plug it into your Git repository, and it will generate 20 practices based on the most repeated comment. So for example, here, this comment, so this little comment, generated this practice, include full error details in error payload, with a description and a positive and negative example coming from my Git repository. So we have the before and after, so we are able to generate those examples. And it will also say why this is a positive or negative practices and why it has been generated. So if I click on that, you can see the sources of this practice generation. So you can see that there is multiple comments that led to this practice. So maybe it's just one comment, or maybe it's more than one comment that generated this practice. So now that you have those practices, you can just validate those. And once a practice is validated into Packmind, automatically we will use AI to generate a program to detect this practice. This is really important to just not ask the AI to detect the practices by itself, because it will lead to a lot of false positive and it will be really expensive to do it all the time within your ID. So the idea of Packmind is once you validate a practice like this one, in the detection part, you will see how this is working. So it will be run into the background, but in fact, it will generate some guidelines for the detection, some control. It's like unit test for the practice detection. So the AI will generate unit tests to see if this practice is well detected or not. And you can add unit tests by yourself by saying, okay, there is an edge case, for example, I will add a test. And now Packmind will have to detect this edge case also to be able to well detect this practice. And once those unit tests has been generated, it will generate a program that will detect the practice. That is good because this program is deterministic, like a linter rule from Sonar, for example. And you can run this program every time that you want within the IDE and in the CI. So in fact, once this practice has been validated by someone within the team, if I go back into my IDE and I had a catch with a payload with error.message like this, I will have Packmind that will identify that there is a violation here. I should include the full error object in our ending payload. And I will also have a code suggestion for this specific example. So it will really be able to use the description of the practice and the positive example to generate a correction for my code here that is really based on the practice. So this is really related to your context and your choices. This is what is really interesting. So this way you have this kind of linter within your IDE, and you also are able to launch this detection within the CI, for example, like a quality gate from Sonar. And you can even integrate the Packmind practices into the Sonar reports. So you have all the practices you have within Sonar and Packmind together. And if you are using GitHub Copilot, for example, you can use Packmind to generate the Copilot instruction. So this is a file at the root level of your project. And in this file, you will add some context to Copilot. So with Packmind, you are able to generate a lot of instruction based on your base coding practices. So you can have, for example, 100 practices, and Packmind will generate a short report with those practices. And Packmind and Copilot, when you will use it, will generate some code that follow your base coding practices. So for example, here, I'm in a hold Java test class. And if I'm using GitHub Copilot with the chat, I just ask Copilot to refactor this file. And like this, refactor this test file. And Copilot will now use my base coding practices with, for example, use the AAA system, reduce duplication, etc. And we generate some codes that follow our base coding practices. So this is a way to just add some context in the Copilot instruction. For example, here it's saying that it uses this reference. In JetBrains, you need to add it manually, but in VS Code and in a few weeks, I think, in JetBrains, automatically GitHub Copilot will read those Copilot instruction file. It's working the same. It's working the same with Cursor or Windsurf. In Cursor, there are the custom rules, the Cursor rules files that you can have within the repository of your project to customize the output of Cursor. And now the new agent mode. So this agent mode is also available within VS Code, for example. So here, I will show you how it's working. So we use the agent mode of Copilot or Cursor to generate some code, but in maybe more one file. For example, if you just ask Copilot to generate a feature, a complete feature, or some test case, etc., it will have the context of your whole repository, and it will generate one or maybe more files that match the feature you are requesting. So for example, here, I ask Copilot to generate a new method called update discovery workshop name from store, because I have the creation method right there, and I want now the update method. So by default, GitHub Copilot will generate some code, that match what I just asked it to it. But you can see here that there is a mistake within this code because Copilot directly added in the payload the error.message. That's the main issue with this AI coding assistant because they just amplify what they saw. So if they saw some security issues or some bad practices within your code legacy, they will just repeat those mistakes again and again within your code base. And promise me, you don't want to have some more code legacy within your new code base. The idea is really to be able to generate some good code that follow the best practices you have right now, to be sure that every new code that is added within the code base follows the practices you discovered within the years. So right now, with the Packmind integration, once Copilot has generated this code, it will ask us to run the npm run Packmind CLI command. So it will run Packmind by itself. And with this run, it will have some answers from Packmind that will say, for example, here, you have a violation within the code you just generated. So GitHub Copilot saw that there is those two violations, line 82 and 109. And it's saying, according to the linter, we should include the full error object in error handling payload, etc. And it will automatically make the refactoring, make the correction. It will say to us what it just did. For what it just did. For example, here I say, okay, before we had that, after we had that, he's saying that this change aligned with the coding practices, etc. So it had a lot of verbosity around that. But what is good is that with this integration, you can now be sure that if the team are using more and more coding agents to generate some code, you will spread your best coding practices across the whole organization. If you have 100 or 1,000 of developers within your organization, you can be sure that with your Packmind practices that have been automatically captured, for example, you will spread those practices in the new code base, in the new code that have been generated. Based on this linter mode with Packmind, with the detection, and with the integration of the new coding agent. So that's why we think about Packmind as the Tech Lead Copilot. GitHub Copilot is really here to help the developer writing more code faster. But when you write some code faster with those AI coding assistant, you will have more code reviews, or you will have more comments within the code reviews. By default, when you create some code with AI, it lasts 30% more during the code reviews. So you have more rework, you have more comments, etc. So really the idea of Packmind is to reduce this overload of code reviews and work for the technical leaders. It's really a way to help the technical leaders to share those practices automatically without having to repeat them again and again during those code reviews. So thank you everyone for your attention. I will share you the link of this video at the end of the meeting. And if you have any question, feel free to ask them directly within the chat. I will also send the link. If you want to try Packmind, you can just click on subscribe here. You can generate an organization and you can try every feature. It will be free for you. And if you want to try it with your team or your company, it's free for 30 days. So you can try it, generate as many practices as you want. Try this integration with GitHub Copilot, for example. And if you agree that it's really good and is really helping the technical leader and the team, you can obviously subscribe and buy some licenses. And we have a question from Jean up. Does Packmind ship with already included best practices? That's a really good question. If you click on subscribe and try Packmind, you will see that you have 12 best coding practices by default. Those are really basic practices that just pop within your organization. You have also a space called Arola best coding practices that will be generated. And within this space, you will have more than 50 practices about hexagonal architecture, about DDD. So those are examples also for practices you can have within your project. And we are already working on creating a hub of best coding practices. It will be some GitHub repositories with markdown files, and each markdown files will be a best practice. And we will have hundreds of practices about Java, React, about some really specific practices also. For example, we have some catalogs coming from Confluent, which edit Kafka. So we have a lot of practices about Flink, about Kafka, about Spring, about really specific practices you need to push within your company. So we will have those hub of practices, and everyone will be able to contribute, etc. It will be available in, I think, 1 month. So maybe in 1 month we will have those hub, but we still already have the Arola best coding practices about hexagonal architecture and the Confluent and the AWS practices. Up. And Fabien, you just asked a question, how to activate this feature with JetBrains. You say that we have to do something manually, if I'm correct. Yeah, if you are talking about this AI agent mode, I think within JetBrains, you only have Copilot edit right now. So maybe in a few weeks, Copilot agent will be available within JetBrains. So in VS Code, for example, you can switch between ask, edit, and agent. And within, because it's always the first version they release with Copilot is on VS Code. But with JetBrains, it will be available in a few weeks. And then for this integration with the agent, it will be the same as VS Code, so it will be automatic. But if you ask something here in JetBrains and you want GitHub Copilot to use your Copilot instruction, you need to click on this button to add this Copilot instruction file within your context. So I just add it, and then I can ask everything, and it will use my Copilot instruction. But in VS Code, it's also automatically, I think it's, yeah. If you just ask something in GitHub Copilot in VS Code, you will see that it will always use this Copilot instruction reference if you have this file. But still, it will be added in JetBrains, I think, in a few weeks. Everything you see in VS Code is normally added just a few weeks after in JetBrains, because they start by working on VS Code. You're welcome, Fabien. Quentin, you're saying, can you customize when a practice is detected in the code? Yeah, that's a good question. In fact, when you create some practices and validate those practices, automatically the detection system will be launched, and this practice will be detected everywhere within your code base, within your IDE, etc. But if you want to customize those instructions, so you just need to open a practice from Packmind, go into the detection part, and then, so you have this AI configuration here that is working. But if you click on configure, you will see that you will be able, as I said, to add some controls, to add some tests that need to be validated for the practice to be detected. So you can add or edit the existing code snippet, for example, here. And here you have this section, detection scope, where you can add some inclusion or exclusion for some files pattern. So you can see, for example, this practice may be detected within the front-end part in this app folder, for example, or for every controller file or every test file, for example. So this is where you can add those filters to be able to really specify where this file need to be detected. And in the future, we will, I think, make the same kind of thing as ESLint or SonarLint by creating some files in the root repository of your project, like a .packmind file with some specific detection rules for your repository. To say, okay, in this repository, we need to apply those rules and you need to exclude those folder, etc. And another question from Jean. I may have misunderstood the part. When Copilot generates new code, it does not take into account the best practices first, so Packmind suggests a second prompt to fix the first result. Yeah, in fact, if you add in the GitHub Copilot instruction like this, the practices you want Copilot to apply, normally if you ask Copilot to do something, it will use that as a context and it will generate code that match those practices. But the really interesting thing is that Copilot is not deterministic. And since we are using AI, sometimes it will work, sometimes it will just bypass this instruction and maybe generate some code that does not follow your best coding practices. That's why it's important to have this Packmind detection, which is deterministic, to be sure that when you generate some code, so for example here, once he generated the code, it runs the Packmind analysis to be sure that within the code, there is no remaining violation. And if you have a lot of practices within your team, for example, if you have 100 of practices about security, test, accessibility, front-end, back-end, etc., maybe Copilot will just not follow every practices. So that's why when he asks Packmind to run this analyze, he will have the violation lines with the name of the practices, etc. And it will be able to fix explicitly those practices. And we are also using, now we are creating some MCP server to be able to communicate with more specific things with GitHub Copilot. So the idea is that when Copilot will try to fix those practices, it will be able to call Packmind and to see if there is a specific way to fix this practice, for example. So the MCP for Model Context Protocol system would be used for GitHub Copilot to communicate with Packmind and to have the list of practices, to have the way of fixing practices, etc. So Jean, you are saying the Packmind detection is deterministic, but the detection program is generating using a non-deterministic AI. So how variable is the detection? Is there a way to test the detection? Yeah, that's a good question. In fact, the detection program, you well understood, is deterministic since it's a program. But since we are using AI to generate this detection program, like this one for example, so it will check a lot of things on the AST, etc. But this program may be regenerated again, etc. So the idea that we use the guideline generated by the AI based on the name on the description of the practice to help the AI to generate this program by saying, okay, I will look for keyword, for example, here, such as constructor, etc. And it will do a lot of check after that. But we use the configuration controls to check if this detection is accurate and to customize also this detection. So by default, when you just validate a practice, Packmind will generate 3 code instruction here. So unit test, it will have one thing that it should respect. So for example, here, it generated this code example by saying, okay, this is a good way of coding things, but this is a violated example. So it will see if the detection catches this violation for this one also. And it will also use the code example you identified yourself, for example, from the practice. So directly from the IDE, I can select a piece of code, make a right click, and with Packmind, I can identify an existing practice and say, okay, this is a negative example also for this practice. You didn't identify it, but I need to update the detection system. So with those configuration control, you can add some new example, etc. And then it will rerun the program generation, and you can still try the configuration for the generation here. But that's really an iteration on the detection. Normally, more than 80 or 90% of the time, you don't have to update it. But for example, if you see something that is not detected within your IDE, you can just do what I just did. You select a piece of code and say, okay, this is also related to, for example, this practice. And I will just say, okay, this is still a negative example for this practice about AWS, and it will update the program generation. And if you want, you can also launch the whole Packmind Analyze on a whole code base, a whole project, by using the CLI directly. So the CLI is right there, and you can use it within the CI directly, or you can just use it to analyze the whole project. And that's what is used by GitHub Copilot, for example. It uses the CLI to analyze the code it just generated to be sure that there is no violation. I will just add also this link into the chat. So thank you, everyone. If you don't have any more questions, so I will send you the replay by email. And if you want to try it or just to discuss with me, feel free to contact me, and you can just create an organization on subscribe.packmind.app. This way up, for example, you will just be able to enter your mail. It will generate an organization. So you can just select the name of the organization you want. You can invite as many people as you want. You will have every capabilities of Packmind. You can also have the Docker version of Packmind. So it's not only in the cloud. You can also use a self-hosted version of Packmind, and you can plug Packmind into every LLM that you want. So in the settings, you have this AI settings where you can select OpenAI or Azure or everything that is OpenAI compatible, for example, Mistral or Claude, etc. from Anthropic. So you can really be sure that everything is set up within your context and your organization. So yeah, if you want to try it, you can just try it by creating an organization, and you can try it for 30 days, and then feel free to reach me if you have any question. I see, Jean, you are still taping. Yeah. So thank you, everyone, once again. Jean, you are saying we can see that in private. But you have a non-profit organization pricing. That's a good question. It's free for open source project, and it can be free for non-profit organization. It's free also for school, obviously, and for open source project. So yeah, there is still a lot of things you can try, and the open source hub of best coding practices we will release will also be free, and everyone will be able to contribute and add some new best practices about everything. So thank you, everyone, once again. Have a good day, and feel free to reach me if you have any new question about Packmind. Thank you.